Hello everyone and welcome back to my channel. I am Manasha Jayaratna and today I will be taking you through a complete and easy to understand overview of computer architecture and CPU performance. Whether you are a beginner, a student or just cautious about how computers really work, this video will help you understand how the CPU functions, how data flow inside the computer, and how modern processors achieve high performance. So let's begin. These learning objectives are: identify the main function unit of a computer system, explain how the CPU processes instruction, compare von Neumann and Harvard architectures, describe key factors that influence computer performance, and understand modern processing technique and system classification. Main functional unit of a computer system. To understand computer architecture, we first need to look at the main functional unit of a computer system. A computer is built using five major parts: CPU, power supply unit, storage unit, input-output unit, and memory unit. Control processing unit is this is the brain of the computer. It processes data and execute instructions. Power supply unit provides the electrical power required for every component. Storage unit, this stores our files, application, image, everything, even when the computer is turned off, computer power is turned off. Next one is input-output unit. This handles all input and output devices like keyboard, monitors, printers, and so on. Last one is memory unit. This temporarily holds data and instructions so the CPU can access them quickly. All these units work together continuously to perform even the simplest task like opening an app or typing a message. Functions of major units. Each unit has a specific purpose. The CPU handles calculation and decision making. The memory unit stores active data needed by the CPU. Input devices send information into the computer. Output devices show us the result, and the power supply unit keeps everything alive with power. Understanding these helps us see how each part contributes to the full processing workflow. Next, I move to fetch, decode, execute cycle. One of the most important concepts in computer architecture is the fetch, decode, execute cycle. This is how the CPU processes every single instruction. Fetch, the control unit, retrieves the next instruction from memory and places it into a register. Decode, the CPU analyzes the instruction to understand what needed to be done. And execute is the ALU performs the required operations such as adding numbers, comparing data, or moving information. This cycle happens millions or even billions of times every second in modern processors. Without this repetitive cycle, no program could run. Data transfer between memory and CPU. Data inside the computer travels through special pathways called buses. There are three main types: address bus, data bus, and control bus. Address bus. This is used by the CPU to point to a specific memory location. Data bus. This carries the actual data to or from memory. Control bus. This manages operations such as read or write. Inside the CPU, there are tiny temporary storage areas called registers. Registers are extremely fast and help the CPU keeps instructions and value ready during execution. This entire communication process is essential for smooth and fast processing. What is von Neumann architecture? One of the most influential computer models is the von Neumann architecture. In this architecture, both instruction and data share the same memory and the same bus. Because of this shared design, the fetch, decode, execute cycle becomes simpler and more efficient. Most modern computers, including laptops and desktops, follow this architecture. Von Neumann versus Harvard architecture. However, there is another architecture called Harvard architecture. The biggest difference is that Harvard uses separate memory for instruction and data. This means it can fetch instructions and read write data at the same time, improving performance. It's often used in microcontrollers, DSP processors, and embedded systems. Von Neumann is simpler and common in general-purpose computers, while Harvard is used where speed and efficiency are critical. Now let's talk about what affects CPU performance. There are three main factors: clock speed, memory size type, and number of cores. Clock speed, how fast the CPU complete instruction per second. Number of cores, more cores allow more tasks to run simultaneously. Instruction level parallelism, number of cores, how efficiently the CPU can handle multiple instructions at once. Modern processors are use advanced techniques to boost these performance factors. CPU functions. Steps in designing a processor: define the instruction set, design the data path, design the control unit, and integrate memory and input-output, test, evaluate performance. Next, instruction set impact on processor design, determines hardware complexity, affect number of operations CPU must support, and influences cost, performance, and software compatibility. Define instruction set and significance. An instruction set is a collection of operations a processor can execute. Next type of instruction: arithmetic, logical, data transfer, and control. Type of processing. There are several types of processing techniques used in CPU design. Single cycle processing. Each instruction completes in a single clock cycle. This is simple but requires a slow clock. Next, multi-cycle processing. Instructions are broken into multiple small steps, allowing flexibility and better performance. Pipeline. This is like an assembly line. Multiple instructions overlap, so while one is being executed, another is being decoded, and another is being fetched. This significantly increases speed. Last one is superscalar processing. This takes pipeline further by adding multiple pipelines, allowing the CPU to execute several instructions at the same time. These techniques dramatically improve how many instructions a CPU can complete per second. Now you can see how pipeline improves throughput. Next we are moved to superscalar vs scale. A scalar processor can only execute one instruction per clock cycle. A superscalar processor, on the other hand, can execute two or more instructions per cycle by using multiple pipelines. This leads to faster execution, better use to hardware, more efficient parallel processing. Most modern processors, including Intel and AMD CPUs, are superscale. Price classification. Price classification is a way to categorize computer architecture. SISD, single instruction, single data, standard sequential computers. Next, SIMD, single instruction, multiple data. Vector processors, GPUs. Last one is MIMD, multiple instruction, multiple data. Modern multiple core CPUs, distributed system. And MISD, rare use, particularly non-exist. These categories help us understand how computers handle different levels of parallelism. And that brings us to end of presentation. Today we covered everything from basic computer components to advanced CPU processing techniques and parallel architectures. Thank you so much for watching. Bye bye.